So this is our first lesson on Unit 17, and Unit 17 covers geometry. Specifically, it covers geometry of planes, or things in 2 dimensions. And what we're probably going to cover in this first lesson is we're going to look at some stuff out of Box A. We're going to look at lines and angles, and we might get as far as Box B here, looking at some material on triangles. So the first thing I'm just going to go through is a couple of properties of angles that you're going to have to know. Okay? So if we look at this first picture right here, we have a right angle. Okay? You can tell it's a right angle because of this little square in the corner here. And the 2 angles, it's divided into 2 angles. These 2 angles are what we call complementary angles because they have to add up to 90 degrees. So I'll just say add to 90 degrees. And we can verify that. If we just do 25 plus 65, we get 90. Okay? So 2 angles that go together to make a right angle, a little square in the corner, are called complementary. They add up to 90 degrees. Over here, we have 2 angles that go together to form a straight line. These are called supplementary angles. And supplementary angles are angles that 2 or 3 angles together that make a straight line add up to 180 degrees. Okay? Because the straight line is sort of twice as big as this right angle over here. And we can easily check this if we take 45 degrees, add 135 degrees, we get 180 degrees. Okay? So complementary and supplementary angles. The third property of angles that we have to know is opposite angles. So opposite angles come up when we have 2 lines that intersect, and opposite angles are on the opposite sides of that point where these things intersect. So opposite angles are equal. So in this picture that I've got right here, angle A is equal to angle B because they're on opposite sides of that point of intersection. And angle D and angle C are the same because, again, they're on opposite sides of that point of intersection. Okay. So complementary angles add to 90 degrees, supplementary angles add to 180 degrees, opposite angles are the same size. And what we want to do is we want to be able to use those 3 properties if we're given a picture to solve for unknown angles here. So in each of these pictures, we want to solve or find the measure of the unknown angle. Okay? So in this first picture here, we've got a 70-degree angle and we've got x. We want to find how big angle x is. Now, what do we know about the 70 degrees and the x from this picture? What do they have to add up to? They have to add up to 90 degrees because they are what kind of angles? They are complementary. So if they have to add up to 90 degrees, how can we figure out what x is going to be? So x, 90 minus 70 degrees, is going to be 20 degrees. What about in this second example over here? We've got 2 angles. Put these 2 angles together, they form a straight line. What kind of angles are these? Logan, what kind of angles are these? Or not complementary, but the other one. Supplementary. And if they're supplementary, what do we know that they have to add up to? 180 degrees, absolutely. So how can we find how big angle y is? 180 degrees minus 46. Supplementary angles always add up to 180. So if we subtract that 46, just punch that into our calculator, angle y has to be 134 degrees. Now, this one here is a little tricky. We've got 4 letters here, A, B, C, and D. We've got to figure out what all of these angles are here. So usually there's an order that you want to go into. You want to do these in. I think we should start with angle A here. How can we figure out what angle A is going to be from this picture? What do you think, Riley? What do we notice about angle A and this angle over here? Yeah, how do you know that they're equal? Yeah, they're opposite angles. So we can just say A is 52 degrees. And if we want, we can just put in brackets that these are opposite angles. Is there another angle that we can get the measure of using this opposite angle principle? What do you think, Logan? Is there another angle we can get the measure of using this opposite angle? Which one is 70? Yeah. B has to be 70 degrees, again, because it's opposite to this angle right here. So we've got A and we've got B, and a lot of times it's helpful once you find one angle to sort of label it on the diagram. So I'll put the 52 and the 70 in there. Now, we've got to figure out C and D. What do we know about C and D from looking at the picture? We don't know how big they are, but what do we know about the two of them? They're going to be equal. So if we find one, we've got the other one. So let's write that down. C equals D. How can we figure out what either C or D is? Well, let me draw, I don't know, a line like this. What do we see about C, that 52, and that 70? Put those three angles together, and what do I get? Yeah, they add up to 180 degrees. They form that straight line, so they have to add to 180 degrees because they are, they're supplementary angles. So we can get C by doing that 180 degrees minus that 52 degrees minus that 70 degrees. Punch that into our calculator. 180 minus 52 minus 70 gives us 58 degrees. So C is 58 degrees, and because we know C and D are the same, we can say that D is 58 degrees. So use those three properties, complementary, supplementary, and the opposite angle, to solve for unknown angles in our triangles, in our angles, angle diagrams. The next set of properties that you need to know are having to do with triangles here. So here I've drawn a triangle, and I've measured each of the interior angles. Interior angles are the ones that are inside the triangles. So this 50 degrees, this 84 degrees, and this 46 degrees are all interior angles. If I take these three angles and add them up, 50 degrees plus 84 degrees plus 46 degrees, put this into my calculator, punch these in, I get 180 degrees. And this is true of every triangle that you can draw. Every single triangle, if you take those interior angles and you add them up, you will get 180 degrees. So for a triangle, the interior angles add to 180 degrees. Another property of triangles we can find if we take a look at what's called an exterior angle. So if I take one of the sides of the triangle and I extend it, I form an angle on the outside. That angle there is called an exterior angle. Now, how can I figure out how big this exterior angle is? Just by looking at this thing here. What do I know about this x and this angle right beside it? The 46 degrees. What do those two angles have to add up to? 180, yeah, because they form that straight line there. They are supplementary angles. So let's figure out here, let's just move that up there like that. That exterior angle is going to be 180 minus that 46 degrees. And we work that out, and we get 134 degrees. Okay. Now this is the property. that you have to remember, that you can remember, that makes a lot of these calculations easier. If I start from this exterior angle and I go to the opposite side of the triangle, I have two interior angles over here. 50 degrees and 84 degrees. If I add them up, what do I get? 50 plus 84 gets me 134 degrees. Okay? So an exterior angle of a triangle is always equal to the two interior angles that are on the opposite side. You add up those two interior and you get the exterior angle that is on the opposite side. So let's just write that out here. Put this in red. An exterior angle equals the sum of the two opposite interior angles. Okay? Angles, because there's two of them. Okay? Now the third property of the angles of triangles is, let's say I extend all of my sides and I make three exterior angles. Here, here, and here. Okay? I can figure out how big each of these exterior angles is. I already know that this one down here is 134. Whoops. Because I found that in the previous question. I can figure out what angle B is, okay, up there, by doing the sum of the two opposite interior angles. So that's going to be 50 plus 46. Oh, not 49, but 46. 96 degrees. And how can I figure out what angle A is going to be here? What two numbers do I have to add together to figure out angle A? Sorry, which two? Not 50. We want the ones on the opposite side. So the 84 is good. 84 and 46. It's got to be on the opposite side. So if I add those up, I get 130. Now what if I do 96, so my one exterior angle, plus my 130, plus my 134. And I add up those three exterior angles. Punch this into my calculator, and you know what I get? 360 degrees. That's going to be the same for every single triangle. And in fact, it's going to be the same for every kind of shape, no matter how many sides there are. You make those exterior angles and you add them all up, they'll always add up to 360 degrees. Okay? So I'm just going to write that here. So the exterior angles add to 360 degrees. And we want to be able to use those three principles, okay? The interior angles add to 180, the exterior angles add to 360, and one exterior angle is equal to the two opposite interior angles, to answer questions where we're given a triangle and we're asked to find the missing angles. Okay? So let's take a look at, I got 4 triangles here. I'll try each of these questions. Oops. So what is our unknown angle in this first one? What angle are we trying to find? Let's give it a name here. We'll call it angle A, because it's up there. What do I know about these 3 angles in my triangle? Riley, what do I know about those 3 inside angles, those 3 interior angles? I have to add up to 180. So how can I find angle A? Yeah, I can take 180 and I can subtract that 36, and that 46, and that'll give me angle A. So punch that into my calculator, 98 degrees. Okay? Let's take a look at the second one here. We want to find this angle A over here. Now, is that A an interior angle or is it an exterior angle? It's an exterior angle. Now, what do we know about that exterior angle in a triangle compared to these two angles on the opposite side here? How can I find out angle A here? What do you think, Logan? How is that exterior angle related to those two interior angles that are on the opposite side? Yeah. Okay, let's go back and take a look. What does it say right here? Right. So how can I figure out what A is then? What do I add? Yeah, I add up 55 and 61, and that'll tell me what angle A is. So I do that addition, 116 degrees. Okay. Here, I want to find angle B. Now, is angle B an interior angle or an exterior angle? Okay. Interior or exterior? It's an exterior angle. And we are told the measures of an exterior angle over here and an exterior angle over here. So what do we know about those three exterior angles of the triangle? What do they have to add up to? It's either 180 or 360. Which one is it? Yeah, they have to add up to 360. So to get angle B, we just have to do 360 minus 137 degrees minus 93 degrees. Punch that into our calculator, and we get 130 degrees. Okay? Now, you're probably thinking to yourself, how am I going to remember all of these properties? Okay? There's a lot of them to remember, but this is why you get the summary sheet on the test. You can write them all in the summary sheet, and then you can just go back and refer to it. So you don't have to memorize them, you just have to make sure you get them all in the summary sheet. Okay? All right, the last one we're going to do here is one that we haven't quite talked about yet. We've got a triangle here, okay? But it's a special kind of triangle. We've got two sides that are the same length, so that makes it an isosceles triangle. Isosceles triangle, okay? And what we have to know about isosceles triangles are two sides of the same length. The angles that are opposite those two sides that are the same length are the same size. So if this one over here is 31, this one in here has to be 31 degrees as well. Now how can we figure out what angle A is? Jake?
You add them up and so you 180 minus 2.
Exactly. The three interior angles have to add up to 180 degrees. So we take off a 31 for one angle, a 31 for the other angle, and that's going to leave us with, punch this into our calculator, angle A has to be 118 degrees. Okay. And I think that's where we are going to stop.